Okay, we are on page 3 of our atomic compound notes. We are going to look at the other type of bond now, which is called the covalent bond. So we've just learned that ionic bonds form in their strong electric charge bonds. In contrast, covalent bonds are a weaker bond. Covalent bonds occur when electrons are shared between multiple atoms, okay? So we don't call them ions in a covalent bond because we don't get these charges. What happens instead is that the electrons have shared orbits. What that means is that the electrons are actually going to both travel around both of the atoms or multiple atoms that are in this compound. The thing about covalent bonds is when these form, they form a compound, a special compound called a molecule. And this word molecule only applies to covalent bonds. Now you're going to see a lot of molecules in your science career, and especially when you get to biology. Molecules are come in all sorts of sizes, and they're very big, important molecules like DNA. But in this case, we're going to learn a diatomic molecule. So diatomic molecule is something that has two atoms. Again, that's not too terribly hard to decipher, diatomic. So an example here is chlorine. Chlorine gas, which has the two chlorine atoms in a covalent bond. What would this look like if we were to have chlorine in a Lewis dot structure? Well, we've drawn chlorine several times now, so I'm just going to draw like so, and I'm actually going to put the other chlorine right here. So I'm going to have two chlorines. We know that chlorine has 7 electrons. Okay, and instead of drawing the electrons as dots on this one, I'm going to actually draw them as X's. That's just so we can tell them apart. Okay, so you already remember that we like octets. This is no different for covalent bonds. The atoms still want to have a octet of electrons surrounding it. And so what's going to happen here is, well, you probably see that there's a place or a location that this one would really like to share another electron. And so that electron can be shared here, and this electron can be shared here. And what that ends up happening is we can redraw that to show that this chlorine now has shared those electrons, and that will eventually look like this, where we have a line between representing a bond, and this line right here represents the covalent bond. We call this a single covalent bond, this bond between the chlorines. What that means is sometimes this little electron, this X, is going to circle around this chlorine, and sometimes this little X is going to circle around this chlorine. It's going to orbit both, and that common shared orbits is what holds these chlorines together, and that's called a covalent bond. So this one is a rather weak bond. Let's see, you can't see that very well. Weak bond compared to the ionic bond. All right. Let's draw one more for practice, which is oxygen. Okay, if we look at oxygen in our periodic table, I'm just going to grab out my periodic table of elements and find oxygen. Where is oxygen? Oxygen's right here. Oxygen is in group 16. It has 8 as in its atomic number. So if we were to draw one oxygen, it's going to have 6 free electrons. So 1, 2, 3, 4, 5. I'm going to draw my 6th one right there. For that one. And then I need 2 of these because this is a diatomic molecule. I'm going to draw my other oxygen here. 1, 2, 3, 4, 5, 6, just like so. And here what again I notice is that this oxygen, in order to become an octet, really wants 2 electrons. Same thing here. Well, that's just nice because these guys, this one wants to share that one, this one wants to share that one. So these 2 will be shared and those 2 will be shared among both oxygen atoms, nuclei. So what that will look like, we can redraw it. We can just sort of rotate, you can imagine rotating this around. This one and that one. These 4 electrons end up being shared by both oxygens. When they share 4, you probably see what's coming. That is going to be what we call a double bond. And the double bond is represented by 2 lines. And we can call this a double bonded molecule. There's actually 2 covalent bonds here because it's actually sharing 4 electrons, but we call those 2 bonds. Okay. Well, again, you're going to do more practice with covalent bonds later on. So I'm going to actually skip this check-in question. We'll come back to that later. We're going to return to some ionic bonding, and then you'll do some practice with that, especially with the naming. So we're going to take a look down here at the bottom of this page. This is the last thing on this page, and then we'll do one more video for the 4th part. And so we're back to ionic bonding. For binary compounds, there are only 2 different types of elements. This is the simplest type of binary compound, is the simplest type of ionic bond, and the simplest ones to name. We already saw that we have, if you remember, our metal plus the nonmetal. The metal goes first, and then the nonmetal ion comes next. So the metal ion is first, the nonmetal ion is next when we name it. And then we call the second nonmetal ions, they end with "ide." And so instead of chlorine, it'll be chloride, and you can probably fill in the others. I'll just show you the answers to those. We'll do a little magic trick here. Okay, so here's your actual answers: chloride, fluoride, nitride, oxide, phosphide, and sulfide. Okay, so one more video for this note sheet on the last page coming up.